This video will examine the impact that both a single bout of exercise as well as regular training have on the immune system. The relatively new field of exercise immunology has emerged over the past 20 years and has generated some exciting results. As the immune system is extremely complex, I will only address some of the key features as it pertains to exercise and one's susceptibility to infections. Our bodies are constantly exposed to a number of infectious agents that could potentially make us ill. Fortunately, for the most part, our immune system does an excellent job of neutralizing these pathogens upon exposure. The two major branches of the immune system are shown here. They are innate immunity and adaptive immunity. While exercise will affect both branches, in the interest of time, I will only focus on adaptive immunity. Adaptive immunity will respond to a specific infectious agent, such as a flu virus, and make immune cells specifically designed to neutralize and kill that specific virus. The two arms of adaptive immunity include both a humoral and cellular component. For the purpose of this video, the humoral arm is responsible for making specific antibodies that circulate in the blood, neutralizing infectious agents. The cellular arm is responsible for making T cells that can kill cells that have already been infected. Thus, when we look at the responses to exercise, I will discuss the ability to make both antibodies as well as these T killer cells. The impact that a single bout of exercise will have on the immune system will be very much dependent upon the exercise intensity. A moderate bout of exercise has only a small or marginal effect on immune function. However, heavy, intense exercise can transiently suppress immune function up to 3 hours post-exercise. Here is one of many studies demonstrating that after an intense bout of exercise, the humoral branch of adaptive immunity, and specifically antibody production, is transiently suppressed at least 1 hour post-exercise. This study was performed on 8 well-trained cyclists who exercised for 2 hours at 75% of their VO2 max. Shown here is the typical response of the cellular branch of adaptive immunity to a single bout of intense exercise. Notice that after an intense training bout of exercise, these marathon runners demonstrated a significant reduction in their ability to produce T cells up to 3 hours after exercise. Again, this immunosuppression was transient as T cell production returned to normal after 6 hours. Taken together, the suppression in both humoral and cellular immunity immediately post-exercise has led to the open window theory. Basically, this theory states that for several hours after an intense bout of exercise, your immune system is transiently suppressed, giving any opportunistic bacteria or virus the chance to get a foothold, leading to infection. You may have already been exposed to these infectious agents before the bout of exercise, but your immune system was effectively neutralizing them prior to the intense bout of exercise. Thus, one's susceptibility to infection is likely greater during the post-exercise recovery period. Possible mechanisms for this transient suppression in immune function after exercise center around the elevation of several stress hormones. These include the adrenal hormones of cortisol, epinephrine, and norepinephrine, which are known to be immunosuppressive. Additionally, an increase in body temperature, as occurs during exercise, may also play a role in immunosuppression. Shown here is the cortisol and epinephrine response from those marathon runners described earlier in this video who had a significant reduction in T cell production 3 hours after a bout of intense training. Notice that both cortisol and epinephrine levels remained elevated when compared to rest for several hours into the recovery period. So does this transient suppression in immune function actually translate into an increased susceptibility to infection? The answer appears to be yes. For the weeks following a big racing competition, such as a marathon, Ironman, or Tour de France, the incidence of infection is 2 to 5-fold greater in athletes who competed when compared to individuals of similar fitness that did not compete. Shown here is just one of many studies that demonstrates this point. Runners who competed in a 56-kilometer race had a 2.5-fold increase in contracting upper respiratory tract infection when compared to their roommates. As their roommates were exposed to the same possible environmental infectious agents, this suggests that it was the bout of intense exercise that made the runners more susceptible to infection. Other factors that can contribute to an increased susceptibility to infection are shown here. I will briefly discuss the interaction between exercise and stress at the end of this video. People frequently ask me if they should exercise when they're sick. Some people believe that the workout will kill any bacteria or viruses and rid the body of toxins. This is absolutely false. In fact, as stated above, a single bout of exercise can suppress immune function during the post-exercise recovery period, thus making the matter worse. The general rule of thumb is not to exercise but rest if your symptoms are below the neck, such as muscle aches, fever, an upset stomach, and lung congestion. If you have symptoms above the neck, such as a simple head cold, it is generally okay to engage in light, easy exercise as tolerated. However, if you find even easy exercise makes you feel worse, then you should stop exercising and rest until you have recovered. As you start to feel better, you can gradually return to your normal exercise pattern. Now let's examine how training can influence your baseline immune function. The majority of studies clearly indicate that participation in regular, moderate physical activity will improve overall immunity. Again, I will show you just one representative study of many demonstrating this outcome. In this study, 3 months of walking in previously sedentary individuals reduced the incidence of upper respiratory tract infections by approximately 50% over a 15-week window of observation. The mechanisms responsible for this training adaptation remain to be determined, but likely involve both branches of the immune system. While moderate training can boost immune function, involvement in repeated high-intensity training will have the opposite effect. As I've already stated in this video, a single bout of high-intensity exercise is immunosuppressive. Frequent engagement in these types of training sessions will chronically suppress immune function, making the individual more susceptible to infections. As shown here, this can result in a weakened immune system that puts the individual at a greater risk for infection, even when compared to their sedentary counterparts. The frequency of infections is a common complaint among many distance athletes. In fact, one of the classic symptoms of overtraining in athletes is an increase in the number of infections resulting from a chronically suppressed immune system. Finally, I would like to discuss the interaction of stress, immune function, and regular exercise. It is well established that repeated or chronic stress can weaken the immune system and can contribute to the onset of illness and disease. Here is just one example demonstrating that regular participation in moderate exercise can reduce the negative effects of other life stressors on the immune system. When sedentary animals are exposed to a stressor, their ability to mount an effective immune response is clearly blunted. However, endurance-trained animals, when exposed to the exact same stressor, show no reduction or impairment in immune function. Similar findings have been found in humans. Basically, moderate exercise training can provide a degree of immune resilience or stress resistance, protecting you from the adverse effects of other life stressors. In summary, a single bout of high-intensity exercise can transiently suppress immune function, allowing an opportunistic virus or bacteria to make you ill. Participation in regular moderate exercise can improve baseline immune function, thereby lowering the risk of infection. Chronic high-intensity training and overtraining can lower immune function, thereby increasing the risk of infection. Regular moderate exercise can reduce the negative effects of other life stressors on the immune system and thus your susceptibility to infections.